Hey guys, before I get started tonight, I just wanted to mention that this is my first recorded YouTube video as opposed to doing a live stream, so do forgive any jankiness. If you've got any suggestions or feedback, feel free to pop it down in the comments. I'd be really grateful to see it. So, leading up to the PowerShell Summit in April and the Iron Scripter competition that's going to be happening there, they're releasing a series of prequel challenges, and I'm playing a bit of catch up here because they've already released the third one. Tonight I'm going to cut my teeth on the first one. So the deal here is that they've given us a snippet of code um, with the understanding that it doesn't work. Uh, so the first thing we need to do is make it work, and then create a reusable artifact, or in other words, deliver a function. Right off the bat, I notice that character there, and I'm pointing that out now because I have a feeling that won't translate through to VS Code. The other aspect of this is that the Iron Scripter event has 3 factions, and I've chosen to go with the Flawless faction. Basically, my interpretation of the Flawless faction is that the code runs flawlessly, or at least any potential errors are handled through error handling. If we've got time, which I don't think we will for this first video, we'll do pester test cases for our code. I'll also be doing my best to avoid any quote-unquote code smells, and in general just sticking to best practices. So like it says here, following our faction's aim is the most important aspect of the challenge. So like I said, Flawless faction. And I'll be targeting PowerShell version 5.1. Alright, so I've just copied and pasted that into VS Code. Now I'm going to be building up all of my solutions as components in a module. So I've set up the framework here. I am going to be using this as a bit of a scratch pad, but it won't end up being saved into the GitHub repo. The final code will end up in the module itself. The link to which, the GitHub repo, will be in the description, so check down there if you want to go and see the finished code. So the first thing we're going to do is get this code working. So as I pointed out before in the PDF, that isn't going to work. The other thing I can spot, thanks to the font I've got going on here, is that is a 0 rather than a capital O. So we'll replace that. I imagine there's probably a couple more issues in there, but let's run this and see what happens. So right there we've got Nate property, which obviously isn't going to work for anyone. So let's change Nate property to Note property and run it again. Okay, so we've not seen any errors this time, but also I'm not seeing my computer name. So let's go see why that is. And that'll be because computer name is unfortunately misspelled. So one more time, let's run that. And it looks like we've got some working output. So what we can see here is obviously that's my computer name, and I have 2 monitors. So now that we've got some working code, let's start by making a new function, which will be in its own file in this module, where we'll start building our final product. So we're using get because we're getting information, and we're looking for monitor information. Let's grab that and pop it in here as our base. So we need to define a function. And just to see how well it does, let's use the built-in format document here. Cool, so that's already looking a lot nicer. So without adding too many new elements to this function, I'm going to do a quick pass and make sure it looks more like something that I would generally script myself. So first of all, I know this day and age that chances are I'm going to get more than one monitor, and we do need to specifically assume that we're going to be getting more than one monitor, and that's clearly demonstrated by the fact that there is a for each loop down here. So I'm going to make that monitors, and I'm going to use a different type of for each loop here, which will be for each monitor and monitors. And this construct for creating an object, I'm not a fan of it. Instead, let's set up a PS custom object and define it via a hash table. One thing you'll note here before I start typing this out is that computer serial here is the computer's name, as is computer name. So what I'm going to do is omit the serial number because it's redundant and yeah, we don't care. On a tangent, we could go off and grab a BIOS serial number or some other sort of identifying serial number, but I really don't think it's necessary for this. So let me go and type this out here. So with those two, I'll just quickly borrow what was already there. Now, one thing to keep in mind here is this for each loop was using a $_ notation. That's not going to work as we expect it to in this for each loop. So we need to refer to each individual monitor as monitor. Should be noted that this $_ still works because we're using a pipeline for each. And while I'm talking about it, I'm going to go change each of those % signs to something a little bit more verbose, but still technically a alias. And with that, we should be able to get rid of all of that stuff and run this. as you can see, we now have some output. We have a computer name, computer type, a monitor serial, and monitor type for both of my displays. So that is still working. So at this point we've more or less ticked off the objectives of the base puzzle here, which is make it work and create a reusable artifact or function. To an extent, we still haven't parameterized anything, but that's about to come. So now I'm going to expand on this a bit and start taking a bit of a flawless faction lean to things and put in some error handling and whatnot. So to start, let's make this, or give it, a commandlet binding. And add a param block. That's not lined up quite right. There we go. So let's start with a parameter. That's going to be a string for our computer name. Our computer name. Now I could leave it like this and make that parameter mandatory by specifying it there. However, what I'm going to do is set a default value. And we can default to the local host. So we've now got a computer name variable we can call upon as and when we need it. And my mouse is acting up, which isn't going to make this fun. So now we can go and specify which computer we're talking about. Cool. And just to double check we haven't broken anything, let's go ahead and rerun this. And it still works. Cool. Right, so one other thing I want to consider here is that a getWMI object has been more or less superseded by getSimInstance, which, if I remember correctly, runs a lot quicker as long as having, I'm sure, numerous other benefits. So while we're here, let's quickly go and change these over to SimInstance, and let's not rely on any of these positional parameters or anything that's not quite done properly. So in here we've got our class name, we've got a namespace. Sorry, I'm just making sure the capitalization is right on that, because otherwise it'll bug me. And also because it'll bug me, that can have a capital as well. Right, and let's do the same for this one. So let's quickly test this again, just to make sure we haven't broken anything. And it looks like we have. So one thing I forgot here was that by defining a computer name on those get some instance commandlet calls, we're going to need to have the Windows remote management service started. So a quick way to do that is run winrm quick config. It's going to go and check what needs to be done and off to make the changes for you. So if I say yes, alright, it needs to be done as admin. So let's try that again. WinRM, quick config, yes, make the changes, and it's done. So now, if we run get monitor information again, it works. So one thing we should try now, however, is a computer that doesn't exist. And we're obviously going to get errors, and we don't want that. So one thing we should probably do when we're doing anything against a remote machine is test that it's actually running. So the obvious way to go about that is, or the way a lot of people go about that is when they've got computer name, they'll chuck in a validate script here and run a test connection inline, which works really well. You'll notice VS Code's syntax highlighting here gets a bit funky. It really doesn't like the a lot of the validate attributes in here. So we'll just soldier along and sort of ignore the ignore what we're seeing there. So this will go ahead and try and ping the machine we've specified via computer name, and it'll give us an error if it doesn't respond, and it will just proceed as we expect if it does respond. So for our local machine, it just works, but for our non-existent machine, we see a delay there as it pings the machine. So this error is a little bit better than what we got up here, because now we know it's not a WinRM issue, it's a the machine's not on issue. However, this looks ugly. Personally, I don't like the output that validate scripts gives you by default. So I'll show you how I handle this, and that is by offloading the validation to another function. So I'm going to make a private function here because it's really only this other functions in the module that are going to be needing it. And we'll call this validate computer name .ps1. And I'll be frank, I've already written this code. You can find it on my blog. If I remember, I'll put a link in the description. But I will just go ahead and borrow that outright. So we've got a function called validate computer. It's taking in the computer name. It's running the test against the computer name, and if it succeeds, it's returning true. If it doesn't, it's throwing a warning saying that the computer name's offline or it doesn't exist, and giving some feedback to the user to check that that's correct and to try it again. So we've got that sitting in there. Let's go ahead and run this to get it into our current session. And let's pop back over to our primary function, and instead of using test connection, let's go ahead and instead use that validate computer name function that we've got. So now, if we go ahead and try to get monitor information from a computer that doesn't exist, we get that custom error message that we defined, where it's telling us that it cannot validate the parameter computer name. The computer doesn't exist, is either offline or does not exist, funnily enough. And then it still gives us a bunch of information. So what happens if the computer is up, it is running, and it is responding to pings, but for whatever reason, say WinRM isn't configured, what is going to happen with these getSimInstance calls? I do have another machine on my network here. I'm not sure if it has WinRM turned on. So let me quickly as you can see, we're getting hefty WinRM related errors from that computer. So it has responded to a ping, but it's not configured to respond to a SimInstance call. So we can handle that with some error handling. We wrap both of these in try-catch blocks, and I am doing one at a time so that we can better tailor our error messages per each of those, so we know which one failed if it happens to be something different. So in the event that our WMI monitor ID call fails, let's throw an error, much like we did over here. And we're just going to type a message out to say that we had an error calling that specific class name. So, error and my spelling is going to be shocking, so give me a sec. Right, so we're throwing an error saying what we couldn't retrieve from which computer. And we'll do the same thing for our other call, and my mouse is being difficult again. But this time we couldn't receive that. Now, this as it stands isn't actually going to trip our try-catch blocks. If I demonstrate that, you notice we're still getting the same errors. That's because a try-catch block is only going to capture terminating errors, and by default, a lot of commandlets don't throw terminating errors. We can force that by changing the error action and setting it to stop. And we'll do that for both of these. Now when we run that and do our failing run of this command again, we now get one error message because it's throwing here, which then aborts everything below it. And it's telling us that it couldn't get WMI monitor ID from that. I think I might add, one thing I like to do with my error messages is provide a little bit of guidance. So you remember here I told them, please check the value and try it again. So what I'll do up here is say, you may need to configure WinRM on the target computer. I'm not going to specifically say what to run, but that will give people a breadcrumb at least to follow. I'm lucky enough not to have this issue personally, but it is possible for a monitor to not have a monitor type. So this value, the user-friendly name, could be null, and if it is null, this construct is going to generate an error, which, flawless faction, we don't want. So what I'm going to do is take this out and set monitor type to an empty string initially. And we're also going to have to pop this into a variable. So let's consider our user-friendly name. So we're worried about it potentially being null. And if it's not null, then we can set the monitor type property of our monitor info object. Sorry, I'm struggling with my mouse here a little bit. To what we want it to be. Otherwise it'll be an empty string, which is better than an error. Let me clean up here a little bit. So we're very much on the home stretch here. Let me just rerun this now to make sure it's all still working. Right, I've forgotten to actually output our object, because of course I'm storing it in a variable now. So at some point there I accidentally turned on VS Code's debugger and things got all sorts of confused. So sorry, we're back at it again. Let's give this a run. Let's try our cool. So we're getting our output, and let's just double check that the other system is still throwing out error. Cool. So that's working. We're getting our expected output. We are putting up all the error handling I can think of. One thing I would like to do is throw in some verbose and debug output and make the most of having our commandlet binding there. I guess one thing about being as error-free as possible is if there is something we haven't accounted for, we should be exposing as much information to our user as we can to help them debug it or to provide full reports back to us. So let's put in some verbose output here, just to say basically exactly what our error message says, but this is going to say retrieved and also we do the same thing down here, except this one is a different class. And also for debug purposes, I'm going to write out the information we got in totality as well. So I'm just going to dump the object out. That shouldn't have auto-completed like that, I don't think. And we'll do the same down here. And I think that's about it. We might want to put a try catch here, but before doing that, let me rerun this just to make sure everything's working, which it is not. That is because something is wrong with one of these, and I don't know which one because it's throwing up there. So let's take it out of the try catch block and see what sort of a difference that makes. Right, so what I didn't realize there was that there's no well, PowerShell couldn't transform that monitors object into a string for me, which it can do for the Win32 computer system. So what I'm going to do is I will just pull that one out, and I will pop that back in there. Now I'm going to chuck a try-catch around this, just in case anything weird pops up. Right, let's get our indentation right. Now if anything happens in there, I'm just going to throw an error that says failed to get monitor I'm not being too specific about what happened here, because frankly if something happens in here, something weird's happened, and it probably calls for some debugging. Speaking of which, I know we're outputting the object there, but I'm also going to output it to the debug stream. And hope that it works. Right, so there's our computer system. There is our custom object with the monitor info in it. And there's our second monitor. Cool. So that gives the user a lot of flexibility as far as debugging this if something goes wrong, or just seeing extra information. And let's try our verbose output as well. Cool, I like it. And I think that's that. So our complete package as far as this particular puzzle is the start of a function called IronScripter. We've got one private function, one public function, and in fact in our PSD1 file we should probably specify that function so that it's properly usable. So when this is run as a function, this validate computer name won't be exposed to the end user, but it is available for use inside the module itself. Cool. Out of interest, before signing this off, I'm going to do this format document again. Just see if it makes any major changes. I don't like that. No, nothing too major changed. Cool. So this will be up on GitHub. I'll put the link in the description. And that was our solution to the first IronScripter Prequel puzzle. We'll be working through the other two soon, so keep an eye out for those videos. Like I said at the top of this video, if you've got any suggestions or feedback or anything, do leave a comment down below or reach out to me on Twitter. I'll really appreciate any and all feedback. Thanks for watching. See ya.